Hello everyone, thanks for watching my video today on this introduction to logarithmic functions. Okay, so in this video we're going to basically talk about the basics of logarithms and how to evaluate some, how to convert back and forth between logarithmic and exponential form. To start, let's graph the function 2 to the x, our exponential function that we worked a lot with last chapter. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. 2 to the negative 1 is 1/2, and we get a pretty good graph. Looks like this. Then it says to graph f inverse as well. Well, right now we don't know how to find the inverse of this function. All right, what we would do is we would switch x and y, right? And solve for y. But right now we don't have the ability to do that. So what we could do is simply take all of our points and switch the x and the y. So for example, 0, 1 will go to 1, 0. 1, 2 go to 2, 1. 2, 4 to go to 4, 2. And our graph would look something like this. So there's our graph of the inverse. So a couple questions. What's the significance of the line y equals x? That line is basically a line of symmetry between f and f inverse. Is f inverse a function? Well, let's see. Looks to me like it passes the vertical line test. So yes. The domain looks like it's all positive, 0 to infinity. And the range is going to go down forever and up forever. So negative infinity to infinity. So this graph that we just drew here, this is actually called a logarithmic graph. Let's take a look a little bit further into y. B and y are positive numbers. B does not equal 1. The logarithm of y with base b is denoted as log base b of y and is denoted as follows. So log base b of y is equal to x if and only if b to the x equals y. So this is how we convert back and forth from logarithmic to exponential and exponential to logarithmic. Okay, two log bases that are used often and need to be known very well are log base 10 and log base e. Instead of writing log base 10, which if you want to write log base 10, it's fine, but instead of writing log base 10, it's just log. No base written. If no base is written, we assume that is base 10. And the other one is base e. We don't ever write log base e. Instead, we write ln, which means the natural logarithm. All right, so let's do a couple, just converting back and forth here. So let's rewrite these logarithmic functions into exponential form using this right here. So the base of the log becomes the base of the exponent. The answer becomes our exponent. And this right here becomes our new answer. So this right here is called the argument. And the argument of the log becomes the answer of our exponential. And that's it. So second one, we're going to write 6 to the negative 1 equals 1/6. Let's remember the base is 10, so this is 10 to the third equals 1,000. And for the last one, remember the base here is e, so this is e to the first equals e, because the argument becomes the answer. So pause the video here and try example 2 on your own. I'll put the answers in about 5 seconds after you pause it, and then unpause it when you're ready. So here our answer should be e to the 0 equals 1, which makes sense. Anything to the 0 is 1. Second one, 7 to the 1 equals 7. And last one, 5 to the third equals 125. Slide 2, or going backwards here, rewrite the exponentials in logarithmic. So the base of the exponential becomes the base of the log, log base 2. The answer becomes the argument, and the exponent becomes our new answer. So log base 2 of 8 equals 3. Second one, log base 3 of y equals x. Third one, log base 16 of 1/4 equals negative 1/2. And last one here, log base root 5 of 25 equals 4. I don't know why I put parentheses there. You don't need those there. If you put them, it's fine, but they're not necessary. All right, so once again, I would suggest you pause this video, try example 4 on your own. Come back and check when ready. So you might have wrote this for the first one, but remember log base e means this. So ln of 1 equals 0. For b, log base 4 of 1 over 156 will equal negative 4. And third one, log base 2 of 32 equals 5. All right, so there's a couple basic exponent rules that we need to know for logs. All right, so the first one is going to just generalize this here. So log base 5 of 1. So if we say this is x, 5 to the x equals 1, we should know 5 to what power would be 1. Same thing here. If we said 8 to the x equals 1, we should know what 8 to the what power would equal 1. Third one, if we wrote this as 1/3 to the power equals 1, what power would that be? Again, it's 0. So to generalize this, log base b of 1 would equal 0. All right? Rewrite your answer in an exponential form, so that would be b to the 0 equals 1, which makes sense. So this is our first logarithmic rule. Log base b of 1 is 0. Second rule. So think of it this way. 3 to the x equals 3. 5 to the x equals 5. 1/2 to the x equals 1/2. What would the power have to be for all these? 1. So log base b of b would be 1. So rewriting that would be b to the 1 equals b, which makes sense. Third logarithmic rule. So this would be 2 to the x equals 2 to the third. 1/3 to the x equals 1/3 to the fourth. 7 to the x equals 7 to the 10th. So our first one answer is 3, second one answer is 4, third one answer is 10. So log base b of b to the k is just going to be k. So rewrite this, b to the k equals b to the k. Makes sense. B to the k equals itself. All right, at this point, there's 2 slides of practice. I would like you to pause this video and try these 2 slides on your own. Come back and check your answers when complete. Here's the answers to the first slide. And the answers to the second slide. That'll do it for our video on the introduction to logarithms. I hope you learned something new today. Thanks again for stopping by, and we'll see you next time.